Welcome back to Bite-Sized Breakthroughs, your weekly dose of the most exciting research in the world of artificial intelligence. Today we're diving deep into the fascinating world of running large language models, or LLMs, on our everyday devices. And joining me to break down this research is Dr. Paige Turner, a leading expert in this field, and Professor Wid Spectrum, providing his insightful commentary from the broader AI landscape. Dr. Turner, let's start with the fundamental challenge this research addresses.
Thanks for having me, Alex. The challenge we're tackling is how to make these powerful LLMs, like the ones used in chatbots or creative writing assistants, work efficiently on our personal computers. You know, the kind of device most people use. The issue is that these models are massive, often containing billions or even trillions of parameters. This makes them resource hungry and not easily adaptable to limited hardware.
So it's about bringing the power of AI closer to the user, not relying on cloud-based solutions. Makes sense.
Exactly. And that's where the research on speculative decoding comes in. It's been a promising area for speeding up LLM inference, but most existing methods, Professor Spectrum, have been primarily focused on high-end data center hardware. That's right. They were designed for environments with ample resources, not the constraints of a typical consumer device. This paper takes a crucial step forward by addressing the needs of a much broader audience. It's about making AI more accessible and democratizing its power.
So, Dr. Turner, what's the innovation this research introduces? How does it tackle this challenge of running LLMs on consumer devices?
The main innovation is SpecExec, which stands for speculative execution. This is a novel approach to parallel decoding that's specifically optimized for consumer devices. Instead of relying on traditional speculative methods, SpecExec utilizes a smaller draft model to predict the most likely continuations of the input text. Think of it as a smart assistant quickly sketching out the most probable next words. Then it uses a larger target model to verify those predictions, ensuring accuracy. This parallel processing is what allows us to significantly speed up the inference process.
That's quite a clever approach. But can you break down how the draft and target models interact? I'm not sure I fully understand how this parallel processing works.
Sure. The draft model, which is smaller and faster, acts as a kind of predictive engine. It analyzes the input text and generates a cache of likely continuations, basically a list of probable next words. Now, this cache doesn't guarantee perfect predictions, but it gives us a strong starting point. The target model, which is the actual larger LLM, then verifies those predictions by computing the probabilities for each of the potential words in the cache. The key here is that we do this in parallel, evaluating all the cached options simultaneously. This massively reduces the time it takes to generate the next word, as we're avoiding the need to repeatedly process the input with the full model.
So essentially, the draft model does the initial heavy lifting of narrowing down the possibilities, and the target model confirms the most likely choices. It's like a two-step process for efficient decision-making.
Exactly. And this method is particularly well suited to consumer devices because of the way we handle the model's parameters. Most consumer GPUs don't have enough memory to hold the entire model, so we have to offload it to RAM or even SSD. This is a major bottleneck because it takes a lot of time to transfer the model parameters from the CPU to the GPU whenever we need to generate a new word. SpecExec effectively tackles this by minimizing the number of times we need to load the entire model from RAM to the GPU, saving valuable time.
Professor Spectrum, can you comment on how this approach compares to existing techniques for speculative decoding?
This is where SpecExec really shines. Traditional speculative decoding methods, like SpecInfer, often struggle to scale well with larger draft models. They tend to hit a ceiling in terms of the number of tokens they can accurately generate, regardless of how much data they're given. SpecExec, on the other hand, doesn't have this limitation. It can effectively process thousands of draft tokens, enabling a much higher level of parallel processing. This leads to significantly more accepted tokens for the same budget, resulting in faster overall inference.
So it's not just about being faster, it's about being more efficient. SpecExec effectively uses its resources to maximize the number of accurate predictions. Dr. Turner, what kind of real-world performance are we talking about?
The results are quite impressive. In our experiments, SpecExec achieved interactive inference speeds of 4 to 6 tokens per second for 50B plus parameter models when using 4-bit quantization. That's over 10 times faster than sequential inference on the same hardware. And even with 16-bit weights, we were able to generate 2 to 3 tokens per second, still a significant improvement.
Wow, that's a big jump in performance. Can you give us a concrete example of what that means for a user?
Imagine you're using a chatbot on your laptop. With SpecExec, the chatbot can respond much faster, almost in real time. It doesn't need to take a long pause to process each word, making the conversation feel more natural and engaging. You can ask questions, get answers, and continue the dialogue without that frustrating delay.
That's quite a compelling application. But what about the limitations of this approach? What are the trade-offs we need to consider?
You're right, Alex. While SpecExec offers significant advantages, there are some things to keep in mind. First, it relies heavily on RAM offloading. While effective for many consumer devices, it's not ideal for systems with limited RAM or for SSD offloading scenarios. We're still exploring ways to optimize SpecExec for those situations. Second, the accuracy of the draft model can impact the overall performance. If the draft model makes inaccurate predictions, the target model will need to spend more time verifying those incorrect choices, potentially slowing down the inference process. We're actively researching ways to improve the draft model's accuracy and reliability.
Professor Spectrum, are there any broader implications for the field of AI that arise from this research?
Absolutely. This research has the potential to revolutionize how we interact with LLMs. It democratizes access to this technology, allowing users with limited resources to harness the power of these models. It also opens up a world of possibilities for on-device AI applications, from personalized AI assistants to privacy-focused chatbots. Imagine, for instance, having a medical chatbot on your phone that can provide personalized advice and support without sharing sensitive data with external servers. Or think about AI-powered writing assistants that can help you create content on the go without the need for internet connectivity. The potential is truly exciting.
It's amazing to think of all the possibilities this research unlocks. Dr. Turner, what are the next steps for this research? Where do you see this going in the future?
We're focused on several key areas. First, we're investigating ways to optimize SpecExec for SSD offloading and other memory configurations, making it more broadly applicable. Second, we're exploring how to improve the accuracy and reliability of the draft model, potentially by incorporating techniques like knowledge distillation or using a multi-stage draft system. We're also interested in exploring the application of SpecExec to other AI tasks, such as machine translation or code generation. Our goal is to make SpecExec a versatile and powerful tool that can accelerate a wide range of AI applications.
It sounds like there's a lot of exciting work ahead. Dr. Turner, Professor Spectrum, thank you both for this insightful discussion. Listeners, I hope this has given you a deeper understanding of SpecExec and its potential to change how we interact with AI.
It's been my pleasure, Alex.
And a joy to share this perspective with you and our audience.
And remember, stay tuned for more bite-sized breakthroughs coming soon to your feed. Until next time, keep exploring the world of AI.